This video provides an updated demonstration of the COMETTS TFM training simulation system. This display that we're looking at right here is the COMETTS control display. This is for the trainee to be able to control the playback speed as well as to be able to get messages from other simulated participants in the simulation. For example, the SNS Tower has requested a release for a flight LN204JS at 1230 Greenwich Mean Time, which is the time that we're approaching right here. The simulation started at 1200 GMT and is running at 5 times normal speed. We have a PGUI display that allows us to see the traffic. This is the emulation of the TBFM PGUI display, but we're also showing traffic across the entire NAS so that we can get a visual of the entire scenario. 1200 GMT is obviously very early in San Francisco, but this is exactly the time that the facility would be starting to coordinate with the command center towards figuring out the need for a ground delay program at this particular on this particular day. We also have the TBFM TGUI, and we have the ability to save and recall different display file settings to be able to set up the timelines for different meter fixes and then show the threshold timelines with all of the traffic. You can see here, for example, SkyWest 5562 is an internal departure from Sacramento, so it doesn't have a scheduled time yet because we're assuming that these flights are on APREX and will be scheduled through TBFM. The weather display here is showing the TAF that is established for this training scenario. This training scenario forecast shows VFR conditions through 1600Z and then a stratus layer rolling in during the 1700 hour, visibility going down to 4 miles and a ceiling at 2,000 feet with IFR conditions. And so far we have a couple of METARs that are coming in that are holding true with that VFR condition coming in so far. But the exercise for the trainee will be to plan a ground delay program or whatever other appropriate methods they feel are the right way to go to handle the IFR conditions and the reduced acceptance rate that will result at San Francisco. So to be able to do that, we will bring up our FSM display. We have ADLs that are being created by the simulation scenario so that we can bring up San Francisco and show the circumstances on the bar chart and on the timelines and be able to make plans for that situation that's pending there. So 1700 is when we expect the capacity reduction to come into place. So we'll go into our GDT tools mode. We will run the ground delay program. We're going to use a DAS ground delay program in this case, even though UDP would normally be used because we don't have the information about pop-ups yet in the system. We'll run from 1700 to 2259. We'll drop the rate during the 1700 hour through the 2200 hour to 36. We'll run a 1,000-mile scope program, and we'll go ahead and model that out. It gives us a resulting power run display that we can see here. Everything looks good, so we'll go ahead and run that. This is due to low ceilings, and so now we will send that back to the simulation, sending that out to the airlines and the NAS users to be able to implement this program as it's been indicated. We can go back now to the FSM display. This normally would update, and that's one of the things that we still need to fix in the simulation so that this update occurs immediately. We have not yet implemented that, but as soon as we get the next ADL, you will see the impact of the ground delay program here on the scenario. There we go. So now we can see the brown flights that are controlled. We see that also here on the timelines. It's a little unusual that we're not using all the slots available here in the 1700 hour, so I think there's something that's either not quite right in the way I'm using FSM or in the way our simulation is interacting with FSM, but that's an example of the kind of thing that we can address and refine to be able to get this working exactly right. So now that we have this set up with the ground delay program and it's been implemented, we can go back to the PGUI. At this point now, this traffic is continuing to run at 5 times normal speed, but these flights now are going to be departing on their EDCTs that have been assigned through that ground delay program that we just ran. And over on the TGUI, we can continue to see, for example, the flights as they are coming in through the different fixes. Here, for example, we have SkyWest 5562, which is one of the ones that would need an internal release. We're going to go ahead and do that internal release for this flight. Again, that one will be coming from Sacramento. We can come in here and find SkyWest 5562 and set up a ready time for that flight. It's actually not going to be ready until 1340, and we will put in a desired STA at the fix of 1405 and schedule it for that time. There are a number of things on that panel that still need to be updated to be able to get all the appropriate information connected in, but we've now sent that back to the scheduling process. You can see that a schedule has been assigned for that, but actually what's going to happen is in the next scheduling process, that's going to be, there we go. Now it's been updated to the time that we requested for that flight. So that SkyWest 5562 has an appropriate time at the fix, and we'll be able to see that as the time continues to march forward. So let me get back to that in a minute, but first of all, let's revisit where we stand on our weather scenario. Again, we're going to continue to monitor the weather and make sure that the forecast is proving out as we would expect. In fact, in this scenario, what we've done is the METARs will start to come in and indicate that stratus layer is rolling in much earlier than expected. So in about 10 minutes at 1310, we're going to get an updated METAR that indicates that stratus layer is already starting to impact the arrivals. At that point, we would, for example, probably have a message come up here on this display for the trainee that might be from Northern Cal Tracon or San Francisco Tower or Oakland Center, whichever one we want to set up in the scenario is the appropriate one to communicate that message that would be alerting the trainee at the command center that there's a sudden change in the weather, that the weather forecast was not playing out as expected, and that something needs to be done to be able to deal with that situation. So we don't have that message, popping up right here yet, but when we go over here to the weather display, now you can see right there that METAR is popped up for 1310 and shows that in fact we're down to 4 miles of visibility, light rain showers, and a broken layer with the ceiling at 1500. So with that, we know that San Francisco is going to need to go down to about a 36 rate, and with all of this traffic coming in that we can see, that is going to be a challenge. Looking back at the San Francisco FSM bar graph, we can see that both during the 1400 hour and also during the 1500 hour that we're going to have some challenges there. So we're going to want to go in and do a ground stop at this point. So we'll bring FSM back. We'll go back into GDT mode. We will reload the most recent ADL, and now we'll go over to the ground stop scenario. And in the ground stop scenario, we're going to run this just for 1300 to 1400 because that'll give us enough time to be able to work through the problem here. We're going to establish the scope at first here and see if that's enough to be able to handle the situation. So we can model that out. And in fact, we can see that during the 1400 hour, that does in fact handle the situation, and during the 1500 hour, we will deal with that through getting a GDP out quickly to be able to handle that traffic there. So that all looks good. We will run the actual, in this case, we don't have the issue of subs handled in the simulation yet, so that's something that we need to get added so that the training is true and accurate to how actually things work in the real world. But for now, we're going to ignore subs. We're going to go ahead and send these parameters in the ground stop. Again, we're going to ignore the subs, and that's going to be sent out now to the simulation so that the ground stop can be implemented now through the simulation. Again, we'll go back to the mode here of display of the current timeline and ADL, and once we get that next update, we'll be able to see the ground stop traffic. As we continue to look at the traffic flying in, we can see that it's continuing to come in, and we're going to need to make sure we get that ground delay program out soon so that we don't get more traffic building here. We're at 1325 now. So there we go. We've received another ADL with the updates that have the traffic that's been ground stopped. And I want to just highlight a couple of these flights here to call your attention to. We've got Alaska 1925 from LAX that's going to get held on the ground until 1401. We've got JetBlue 1136 from LA. I'm looking for the ones that are not in Oakland Center because those are still going to be on APREX. And then there's San Luis Obispo for SkyWest 5667. So we'll come back and look at those flights again in a little bit. Again, as we look at our TGUI, just to recall your attention back to SkyWest 5562 that we scheduled previously with the release time, we can see that the schedule has put that flight after SkyWest 3497 and before EJM 402. So if we go back over to the PGUI, just to be able to try to get a feeling for where that flight is going to slot in. There's EJM 402 right there, and there's SkyWest 3497. So we can expect as those aircraft continue to approach that as that aircraft pops off of Sacramento, that we'll see it fit into a hole that will be built between those flights. And again, remember that as those TBFM times freeze, that the simulation is going to control these flights or simulate the control of these flights to those STAs, and so that hole will be built for that Sacramento flight to pop into. All right, but let's go back now because we have talked about the fact that we need to revise our ground delay program to be able to address the reduction in capacity, and we'll revise out of this ground stop. So we're going to go once again back into GDT mode. We're going to reload. We're going to, in this case, again run a DAS mode GDP, but now we're going to start it at 1500. And so we'll be able to get these flights handled. We're going to run a lower rate during the 1500 and 1600 hour. We're still going to do 1,000 nautical mile scope, but because we're revising out of a ground stop, we're going to exempt by status. So at this point now we go ahead and model the scenario. We get the power run for this revised GDP. Everything looks good. Everything looks good here, and it's as we would expect. It's a little bit odd that we're not seeing more flights being used here, and that's probably something that is not quite right in terms of the simulation connecting to FSM, but that we'll certainly be able to address and refine. Again, subs we're going to ignore in this case, but that's something that will be addressed in the future. And now we'll take this revised GDP and we will send that back in to the simulation. And then as we return back to the SFO display, and again watch for an updated ADL, there we go. So there's the 1345. We can see again something weird going on in the 1600 hour. We'll have to figure that out, but you can also see that some of the flights that were ground stopped are still being handled on the ground stop. It looks like maybe they should have started that ground delay program earlier because we're going to have too many flights at this point. And in fact, we can see the PGUI indicating many of those flights continuing to flow into San Francisco. Here again is our SkyWest and our EJM 402, so we can continue to watch those going in. So at this point now we are at 1348. Those flights that are ground stopped, remember that we had JetBlue 1136 and an Alaska flight and a SkyWest flight from San Luis Obispo. We'll see those flights pop up here after we get to the 1400 hour. But again, we can continue to monitor the flow and monitor the operation both from the TGUI display as well as from the PGUI, as well as continue to monitor the FSM display, and these are all integrated together through the entire scenario and simulation as we're watching these flights flow. Now, one of the things that we'll point out about this particular issue of maybe not running the ground delay program early enough or not setting the scope of the ground stop wide enough, that's exactly the kind of thing that we are intending the trainees to be able to experiment with and learn and get experience with through the operation of this simulation environment. And by using this environment, and as you recall, we've been running at 5 times normal speed this entire time. So literally they could run through this scenario 5 times in the same period of time that it would take to simply observe the scenario once if it was done through observation in real time, and even then it wouldn't be possible to manipulate the data the way we are manipulating it here. I'll switch back over to the PGUI and just point out that SkyWest 5562 has departed Sacramento and has come off the ground and is being routed around to these arrival fixes, and will be able to slot right in here between SkyWest 3497 and EJM 402. It's tunneling under a couple of other flights right now as it comes out in this direction. We'll come back and take another look at that. At this point, we're at 1400. We can expect those flights that were ground stopped to be popping off of their respective airports down here in ZLA. So if we just watch for those for just a minute here, we can expect to see those flights coming off. In this case, we probably need to have a little bit more variability. You saw that all those flights popped off at exactly the same time right after the ground stop ended. Although flights obviously do want to get off as quickly as possible after a ground stop ends, it's probably a little bit more realistic if those come off a little bit more staggered, but that's something that can be easily added into the scenario and into the simulation. I'll just go back once again to the SkyWest flight. You can see it continuing to tunnel under some of those other flights, and we'll tuck right in there behind the SkyWest 3497 in front of Flight 402 here nicely. And that pretty much covers the scenario. We've been able to go through a initial ground delay program, a weather scenario that was not as forecast, that forced us to do a ground stop, and then we were able to revise out of that ground stop into an updated ground delay program. I think you see the power of this simulation environment. You also see that there's a few things that still need to be addressed on it, and we are still in the process of developing some capabilities for users to easily select different scenarios and run those. But this would be a significant tool to be able to help traffic management specialists at the command center and at the facilities be able to practice and experience the operational types of issues that arise, and be able to improve the efficiency and effectiveness of traffic management training.